What's up, 20-1? Hope everybody's staying happy and healthy and staying busy out there. Today is the first part of a two-part lesson that's going to be on solving radical equations. I'm going to break this up here into hopefully two smaller videos rather than one big one. So just a kind of something to remember here is that the difference between an equation and an expression is that an equation has an equal sign in it. So we are actually solving for something rather than just simplifying. And we have been simplifying up to this point, right? We've been simplifying radicals by removing square roots or cube roots, by adding, subtracting, multiplying, dividing, and rationalizing. We've just been simplifying. Now we're going to take a look at radical equations. And so a radical equation is one in which a variable appears inside a radical. So something like, the square root of x is equal to 4. That's an example of a radical equation. And this side could get more complicated as we kind of move through. Today's video is going to focus on solving equations that only have one radical. So like that, not something that's like this. Okay, we'll look at how to solve this in the next video. Today we are only going to solve radicals that have one, or equations that have one radical in it. So I wrote out the steps here. The first thing you need to do is isolate the radical. So if there is anything else on this same side as the radical, you need to get it over to the other side, whether it's by adding, subtracting, multiplying, or dividing. Once you've done that, then you'd have to square, because I want to get rid of that root sign, so I would square it, solve, and then check for extraneous roots. And we'll talk through this and what that means as we kind of look at an example. So example 1 says solve for x in the following equations, and I'm just going to kind of use these as a checklist to go through here. So the first thing I need to do is isolate the radical. So that means I got to get this by itself. So I need to remove this positive 3 by subtracting 3 from either side. So now I'm left with the square root of x is equal to 12. Okay, that's done. Second thing is square both sides of the equation. And the reason I want to square this, as I said previously, is I need to get rid of the root sign. And squaring and square rooting are opposite functions. So if I square the square root of x, I'm just left root of 12 is 144. And so I have solved. Now the next part says check for extraneous roots. So I can kind of do this in two different ways. I can just take my answers and substitute them back into my equation. So I could check. So let's check. And so to check, I need to take this number and put it into my original equation wherever there is an x. So does the square root of 144 plus 3 equal 15? Well, the square root of 144 is 12 plus 3. Does that equal 15? Yeah, it does. So that means this is part of my answer. Okay, I can check it that way. And knowing radicals is especially important kind of the function and how to solve and talking about extraneous roots is important in 20-1. And so the reason we need to check for extraneous roots is, so if I go on my calculator and I just type in the square root of x, like let's go see what kind of graph that's going to give me. Well, it gives me this type of function, and that's the square root of a function. And we could look at transformations to that, and that's what you do in 20-1. But that's not what we're worried about. We're just checking for extraneous roots. And the reason we need to check for extraneous roots, because, I have an answer over here at 144, where they're probably actually, way over here at 144. There probably is actually an answer that applies there. But if I had, for example, an answer at like -10, well, this graph stops right here. The reason it stops right there is because we can't have a square root of a negative function. And so my graph, my answers are going to be all numbers greater than that value. So the other thing that we can do is talk about what are the restrictions? And so restrictions is well, that domain is restricted, and it's restricted because it's a square root function and it can't have negative square root numbers. So to figure out a restriction, what I need to do is go look at my radical function and essentially say, I need to make or find where that radical function is greater than or equal to 0. And, if I square this right away, it just gets rid of the square, and that becomes nothing. So the restriction on this particular function is that x needs to be greater than or equal to 0. And this value falls within that restriction. So, it kind of double checks out there. So not only must I check my answer that it verifies within my equation, I must also state restrictions on my domain because x can't be every single value, right? I can't put a negative 12 into here because I can't take the square root of a negative number. And so there is going to be a restriction that I also need to include when I'm talking about my solution. All right, here's another one. And so let's go follow those steps. First thing I need to do is isolate x, or isolate the radical. So I will add 3. And so now I have 2 root x minus 3 is equal to 8. This is 2 times that radical, so I will divide that by 2. Now I'm left with the square root of x minus 3 equals 4. And to solve, I need to square this to get rid of the root sign. So the square root of x minus 3 squared is just x minus 3. And 4 squared is 16. And to finish solving, I'll add in my value. So x is equal to 9. But I want to check that that is actually going to be a solution that works. So I'll check that out, that it kind of all pans out here. So 2 times 16 minus 3 needs to equal 5. Well, 2 times, sorry, that should say 19. 19 minus 3 is 16. Well, 2 times that is 2 times 4. So 8. And this is still minus 3. Well, is 8 minus 3 equal to 5? Yeah, it is. So that answer should work. I also, in talking about this function, or this expression, equation, need to talk about the restrictions on this domain. So I do the same thing as before, where I look at just what's in here. So the square root of x minus 3, we want to find where that is greater than or equal to 0. And I'll solve, so I square that, which doesn't really do anything other than get rid of the square root. So I'm looking for where is x minus 3 greater than or equal to 0. And so to get into something that makes a little bit more sense. So the restriction on the domain, it was to be x would have to be greater than or equal to 3. And if I graph this function, I would see that that is true for the domain of that. So that's kind of my second part. All right, let's go look at another more complicated question. If you think you kind of feel okay, I would suggest maybe trying this question on your own. And then turning back on the video. So maybe take a second to pause and see if you can try this one on your own. So hopefully you've had a chance to solve or paused it. What I need to do is get my radical alone. So what I'm going to do is subtract x from either side. So now I'm left with the square root of negative 2x minus 3 is equal to 3 minus x. Not much more I can simplify here, so I now need to square either side. Squaring on the left side here is going to get rid of that root sign. So now I'm left with negative 2x minus 3 is equal to 3 minus x squared, which is really 3 minus x times 3 minus x. There's 2 of those. So what I want to do now is kind of multiply out, simplify, get everything to one side so I can solve for x, which kind of brings us back into the quadratic unit. So I'll distribute that negative 2 in, so I'm left with negative 2x plus 6 is going to equal 9 minus 3x plus x squared. So simplify that, I'd be left with 9 minus 6x plus x squared. And I want to get everything to one side so I can determine the value of x. So I will minus 6 from either side and add 2x. So 0 is equal to 3 minus 4x plus x squared. And it kind of looks a little weird looking at it like that, so I'm just going to do this. So 0 is equal to x squared minus 4x plus 3. Now I can solve for that quadratic using whatever strategy I want to find my x-intercepts. I could factor, I could use a quadratic formula, I could put it into standard form and complete the square and then square root. But this is an easy question, right? I'm looking for two numbers that multiply to a positive 3 and add to a negative 4. So those numbers would be x minus 3 and x minus 1. So the x-intercepts, or the values for my intersect, are x equals 3 and x is equal to 1. But I don't know for sure. I still need to go check to determine if those solutions work within what I have here. Okay. So if I'm going to check this, I'm going to go the square root of negative 2 x, which I'm saying is 3, minus 3 plus 3 needs to equal 3. Well, this is 0. Well, so what's the square root of 0? 0. So does 3 equal 3? Yeah. So I know this is a solution that works. And I'm going to try the same thing with 1. So the square root of negative 2 times 1 minus 3 plus 3 needs to equal 3. Sorry, plus 1, because that's an x. So negative 2, this is negative 2 times negative 2 is 4. Is the square root of 4 plus 1 equal 3? Well, 2 plus 1 is 3. So that is also an answer that should work. Last thing I should do here is also talk about my restrictions on the domain of that radical function. So the restriction here is going to be, I'm looking at where is this greater than or equal to 0? Where is that greater than or equal to 0? So I square that, again, doesn't do anything other than get rid of that root function. So if you realize, you could just really take what's underneath here and just make that greater than or equal to 0 to solve. So now I have negative 2x minus 3. Where is that greater than or equal to 0? So to solve for x, I need to divide by negative 2. If you remember your inequality laws, anytime you divide by a negative value, you should flip your sign. So this becomes x minus 3 needs to be less than or equal to 0, and I'd add 3. So the restriction on the domain is x would be greater than or equal to 3. Both of these values fall within that parameter. Okay, so that's the first part of this video, which is on solving equations that involve one radical. I do have this question done in the note package if you want to try that for yourself and go check. It's quite a little bit more difficult because you end up with a trinomial where you have to factor using the quadratic formula. It gets a little bit messy. So what I would suggest from here is to go try a few of these questions from number 1. Number 1 is strictly just dealing with one side or one equation before you go into the harder question. So do some questions from 1 and 2 that only have one radical function in them. And then when you're ready for that and you feel comfortable, go check out the next video. Okay, thanks for listening.